All right, the atmosphere, learning target 39, 40, and 41. So we're going to start talking about the hydrosphere. So the hydrosphere is all of the water on Earth. So hydro means water. So it's all of the water on Earth. So that can be water that's in the atmosphere, like water vapor. That could be water in oceans, lakes, glaciers, rivers, and streams. And it can also be underground water that we might not see. So then the atmosphere, that's gases that surround the Earth. So one thing that they have in common is that water vapor, okay? One thing you'll notice about this picture on the right is that the atmosphere is really thin. A lot of times we think of it as being like really, really, really big and thick, but it's actually very thin. So air is made of a few things. It's made of a bunch of different gases, okay? When we look at the breakdown of those gases, most of the gas that's in the atmosphere is actually nitrogen. 78% is nitrogen. 21% is oxygen. And then there's 1% left. That's all of these other gases in really small quantities. So air is also made of water vapor. Okay, so water vapor is just water that's in a gas form. Air is also made of particulates, and particulates are just things like smoke, smog, dust, pollution, any of those things. So they hang out in the air for a really long time because they're super teeny tiny. And they can, if it's smog, it can make you sick. Pollution, obviously, is bad for the environment. But yeah. All right, so why do we even need an atmosphere? What's so important about it? So one of the things that it does is it gives us a warm, stable temperature. It lets heat in, and then it keeps some heat so that we are warm. We're not too hot, we're not too cold. It also gives us air to breathe. It's very important for us. Okay, we have oxygen in the atmosphere so that we can breathe and live. It also protects us from solar radiation. So some of the energy from the sun is really harmful and it gives you like skin, like sunburn, but it's also can affect your cells and give you skin cancers. So our atmosphere blocks some of that harmful radiation. It also protects us from meteorite impacts. If the meteors are small enough, it'll burn up in the atmosphere and it doesn't make it to Earth. So let's look at the structure of the atmosphere. So there's 4 main layers and it's divided by temperature. That's an important thing to remember for your summary questions. That's divided by temperature. So we're going to look at these 4 main layers. So right on top of us is the troposphere. So let's break it down. So the troposphere contains 75% of the air in the atmosphere. So gravity's pulling all of those particles down because remember, air has mass, it takes up space, so it's pulling that mass down. It's good for us because then we can breathe. It also contains the jet stream, which is just a stream of air that flows across or around the world. And it's where weather occurs, right where we are. Now, little hint, the troposphere is right on top of us. That's how you can remember which one is right at the ground. So we're also going to look at temperature, density, and pressure and how those change as we move up. So when we start at the ground and move up, it's actually going to get colder and there will be less stuff in the air, so a lower density, less stuff pressing on us, so a lower pressure also. All right, right above the troposphere is the stratosphere. So the stratosphere contains 24% of the air in the atmosphere, so less air, and it also contains the ozone layer. So that's what protects us from UV radiation. So again, if we look at that temperature, density, and pressure, this time as we go up, because of the ozone layer and the particles in here and the energy that they have, the temperature actually increases in this layer. But because there's less stuff, the density is going to decrease and the pressure will decrease. So above the stratosphere is the mesosphere. The mesosphere contains less than 1% of the air. Okay, gravity has pulled all of that matter down towards us for us to breathe. Whew, thank you. The mesosphere is where meteorites usually burn up. If we look at temperature, density, and pressure, as we go up, not a lot of air here, so it's going to cool down. Not a lot of stuff here, so lower density, less stuff pressing, less pressure. And then the very top layer is the thermosphere. So the thermosphere has two different parts in it. So the ionosphere and the exosphere. The exosphere is the very outside part of the thermosphere that exits into space. So there's a certain point where scientists say the atmosphere ends and you have entered space. So the thermosphere is where satellites are found, orbiting around the Earth. It's also not a lot of air at all, less than 1%. And then it's where our northern lights occur. So the sun, energy from the sun interacts with ions in the thermosphere, and that's where we get those northern lights, those colors floating around in the sky. If we look at temperature, density, and pressure, as we go up, this one's kind of interesting. Because we're out in space and we are exposed to almost out in space, we're exposed to almost that raw energy from the sun, the temperature actually increases. There's less density, less pressure, because there's not a lot of stuff out here, not a lot of particles. When we get out into space, there's nothingness. So there's less stuff pressing on us, so that's a low density, low pressure. So if you look at these trends real quick, just something I want to talk about is that temperature, how it changes, and then density and pressure and how that changes. So if you'll notice first, as we go up, it gets cold first, then it warms up, then it cools down again, and then it warms up. That's an important thing to remember, that as we move through these layers, that it goes from the ground up, cold, warm, okay? The other thing you'll notice is this density and pressure over here, is that as we move up, there's less stuff. So this is lower density, lower pressure, all the way up till we move up, because there's a lot of air down here, but there's not a lot up here. Another thing I want to point out is the order over here, and I'm going to give you a little memory trigger. So I remember it as the most. The most. So the is for thermosphere, is for mesosphere, most is for the ozone layer in the stratosphere, and then most troposphere. And then because there's two T's, remember the troposphere is right on top of us, okay? So we're going to skipperoo. Forgot to delete this, but I'm perfect, remember. Okay, summary questions. Number 1, how are the hydrosphere, water sphere, and the atmosphere similar? So what do they have in common? Number 2, what gases make up the majority of the Earth's air? So think about that pie chart. And then number 3, what are the 4 layers of the atmosphere and how do we divide them? Okay. Best of luck to you all. Bye-bye.